All right, so in this video, we're going to go into a little bit more detail on the dependent pair type and sort of go through some of the examples we mentioned and that we saw in the Wikipedia article. So let's get into it. All right, so last time we looked at this part of the Wikipedia article on dependent types, and we're going to start off with sort of this chunk here. We're going to kind of go through and explain this stuff, okay? So here's how we're going to do it. So we're going to have, first we'll explain just like the normal pair type that they're talking about. Like, where is it? This thing, just the A cross B. So, so I think we're familiar with this. So if we have X is of type bool cross int, then we can have something like true 5. Right? I think that's pretty straightforward. And we can have other examples like y is the same thing, or y's type is the same thing, and its value could be false 6, for example. And then z could also have the same type, and it could be something like, true and then 7. Okay, so that's just a couple examples of the standard pair type. Okay, and so now what we'll talk about is what is the dependent pair type and what's different, what wouldn't work. Okay, um, so one thing we wouldn't be able to do is maybe z1, this one true, and then high. So this one would not work because this high is a string. It's not an integer. Okay, so this one wouldn't work. Okay. All right, so let's look at the dependent pair type. So we're going to have a couple examples over here. So one example would be, I probably don't even need that equal sign, so let's get rid of it. Okay. So let's do something like true and 5. Okay. And then true and 7. And then this one is going to be a bad example. So let's give this in green. Or let's see, I'll do red again. So this one will be true and high. Okay, and I'll explain why this is a bad example. Okay, so let's do a couple more good examples. So let's do false. And this time high is okay. Because in all the trues, what we're going to see on the trues, our output type, our second element type is going to be an integer. That's why this one didn't work. And then on all the falses, our output type is going to be a string. So you can see in what's happening is here, independent of the value we put in here, this type has to remain the same. But on the dependent side, this second type can depend on the value of this first one. Okay, so false, hey, and then we'll do another bad example, false, and then high. Okay, so it's a bad example. All right, so what's happening? If we were going to give this a type, what would we do? We really wouldn't be able to do it at this point in time. So this is exactly what that sigma type in the Wikipedia article is for. This is what this is saying here. Okay, so we're gonna give ourselves an example of this. So in our case, when we have true, we want the output type to be an integer. And when we have false, we want the output type to be a string, right? So what I'll do is I'll just say b. So this is going to be sort of a function that goes from true to integer and then false to string. So I'm going to say x of type bool, and this goes into types. right? And so we just kind of make up a notation here. So if x is equal to true, then return integer. And if x is equal to false, then return string. So this is sort of just pattern matching. Okay. So now what we have here, this b, this is the function that tells us this output type up here. Okay. And so now in our case, what we're going to say is x is going to be of type bool. Right? And then here we're going to have b of x. So this is what's happening in this Wikipedia article. So this type is exactly what we have here, right? That's this thing. So if we were going to call this variable like s equals this or something, this is precisely the type that s would have, is this thing right here. So what you can see, maybe this takes a little understanding or getting used to, but the entire type is really just defined by this function here. So if we had changed this to be not a string but something else, then these would be different, right? If we wanted this right here to be bool, let's do it in a different color. Let's see here. Can I get my green? I don't think so. So if we change this to be bool, right, then these two would have to be bools. Okay. Let's see if there is anything else we wanted to talk about. Okay, yeah. So, and we're just kind of wrapping up here. But there's a couple more things. So first of all, so normally we're used to seeing something like, you can kind of think of it looking like this. So you can kind of think of it as bool cross b of x, right? And here x, this would be x of type bool cross b of x, right? This is sort of the same thing as that, right? You can kind of think of it as whatever's under this sigma, that's going to be the type of the first element, and then the second element is going to be this output type right here. Okay. So I wanted to go through that, and then the one other thing I wanted to go through was in this Wikipedia page. It says, yeah. So if b is a constant function, then the dependent pair is equal to just the normal product type. Okay. So what that's saying is if this b is a constant function, so no matter what we have here, we get the same output every time. So let's say in some hypothetical scenario, b of x, let's get that to be type bool, and then it goes into type, right? And then if we have true, it goes to int, and false also goes to int. Well, this is just going to give us an int every time, so it's constant. So what that means is b is basically an int. So this type would be x of type bool and int. But here, this is just the same thing as just a regular pair type, bool cross int. So that's all this part of the Wikipedia this is saying, is if it's a constant function, you can just ignore that b is a function because it's constant, and then you can just say, okay, this little thing, that's the element of the type of the first element, and this right here is the type of the second element. Good? All right, so let's just make sure we kind of covered this. In the universe of types, there's a type A. So in our case, we had bool. Bool was A. And then B goes from A to the script U. So in our case, B was our function B. And this capital A was bool again, right? Just this same A that we talked about. And this was basically all the types. So in our case, one of them, the ones we used were the string in the end, Okay, and then the dependent pair type, that's what we wrote out. And then we actually just covered all this right here. Okay, so with that, I think we're good there. I think next time we'll go through probably another example with the discrete A set, that the example that we talked about with the NLab and the Wikipedia page. So I think that's all I've got. Thanks a lot.